Hi, in this video we're going to be solving the following operator equation. So the first thing that we're going to do is to find the general solution, obviously. So to find the general solution, it's YGS is equals to YPI plus YCF. So you're going to have to find the general solution by first finding your particular integral equation and then also find your complementary function equation. So YCF simply means a complementary function and YPI means particular integral. So we first need to find, this is number A, we first need to find the YCF. So to find the YCF, we have to find the factors of our operator equation. So we're gonna take this and equate it to 0. So then we find the factors. So the factors here, we have D. Then obviously the factors here, it will be 2 and 2. So which is equals to 0, and then D1 equals to D2, which is equals to 2. Okay, so since the factors are the same, your YCF will be given by C1e D1x plus C2e D2x times x. That's because the factors are the same, you multiply by that x there. Okay, YCF will be equals to C1e 2x plus C2e 2x times x. Okay, we are done with our YCF now. Since we are done with our YCF, then now we go to number B, step B, or step 2. So step 2, we have to find the YPI, the particular integral. So to find the particular integral, just gonna paste the original equation here. So you go back to the original equation. Then on the original equation, you can see that you have y there. So you're just gonna make y the subject of the formula from the original equation. Then it means you have to divide both sides by d squared minus 4d plus 4. So you divide both sides by that. So you'll be left with y. That y that you are left with, we call it YPI. And then you'll have e to the power 2x divided by d squared minus 4d plus 4, and then plus sine x here. So as you can see, you've got two different variables here. You've got two different variables. So we have to split them because this one is using its own theorem. It's a trigonometric equation. So trigonometric equation, it uses its own theorem. And also this one, it's a logarithmic function which uses its own theorem. So they use different theorems. If they were using same theorems, then we're gonna just leave them as they are. But since they are using different theorems, you're just gonna say e to the power 2x divided by d squared minus 4d plus 4. We split them, then sine x divided by d squared minus 4d plus 4. Okay, so I'm just going to explain the theorems separately. So the theorem for this one, so you always check your numerator. So the theorem for e to the power 2x, it's the same as e to the power ax. And then where a is equals to d is equals to a, or a is equals to d. So meaning in this case, so I'm just gonna solve this one. So ax is equals to e 2x, meaning a is equals to d. So a is equals to d. You first identify the value of a and then equate it to d. So meaning d is equals to 2. That's the theorem for a logarithmic function, or e to the power ax. Then we're gonna go back to the YPI. So you will have to say e to the power 2x divided by Where there's d, we're gonna put 2, so you'll have 2 squared minus 4 into 2 plus 4, which is equals to e to the power 2x divided by, so you'll have 4. So here you have 4, sorry, let me use a different color. You'll have 4, this will give you 4, and then it's a plus 4 minus 4. Okay, so as you can see here, we'll get something interesting here. There's something interesting. So you'll have 4 minus 8 plus 4. You'll have this. So you will get undefined here. In this case, you will get undefined. So meaning you will have over 0. So over 0, it means it's undefined. So if your equation is undefined, so the alternative method is that since you got undefined there, so you need to say we take e to the power 2x divided by, if I say d minus 2 all squared, is the same thing, isn't it? It's the same thing because it's a different. It's not a difference of 2 squares. It's a repeating basically. It's not a difference of 2 squares. It's a repeating. So even if I take this one, if I say a is equals to d is equals to 2, you see there you will get a 0. So what we need to do is that this is the another theorem that you can use. Another theorem says where there is d, you're gonna say d plus a. That's another theorem. If you get a 0, this is another theorem. If you get a 0 in your denominator, where there is d, you're gonna say d plus a. So meaning where there is d, you're gonna say d plus 2. So you will have e to the power 2x over, open bracket, I open another bracket because I need to put d plus 2, and then minus 2, then squared. Then I'll have e to the power 2x divided by, now I remove my bracket. So I'll keep this one, then I'll have d plus 2 minus 2 all squared, which is equals to e 2x divided by, obviously these ones will cancel, and I'll be left with d squared. So remember, d originally it was equals to, what this means is that d squared, okay, so let's do this. So d squared, it means 1 over d is equals to integral, then 1 over d squared, it means double integral, right? It means double integral. Keep in mind that you cannot substitute a since you already used it, so you cannot substitute it there. Okay, so it means you're going to integrate twice. So when you integrate once. So integration of e to the power 2x dx is equals to e 2x over 2. And then when you integrate this again, you'll get over 4. That's how you solve the first one. You'll get e to the power 2x over 4 because you integrate twice, 2 will multiply. Okay, so that's our first one. Then we go to the next one. We have sine x over d squared minus 4x plus 4. Okay, so let me do this. So this we can also write it as, because it's repeating. So whenever you solve this one, whenever you solve this, look at this. If we write it like this, we're going to have a problem. Reason being, the theorem, here, let me put wrong. Because the theorem for sine or trigonometric function, it says for all trigonometric functions, the theorem says whenever I see a squared, it must be equals to minus d squared. It's not the same as this, guys. So it's minus d squared. So remember the theorem for trigonometric functions. I'm taking it back to the theorem. The theorem for trigonometric functions, it says sine ax or cos ax. So whatever that you have there as your a, it will be equals to d. Okay, so it says sine ax cos ax. Then you must say minus d squared is equals to a squared. That's what you must say. That's the theorem for trigonometric functions. So we're gonna go back to sine x. So you see the reason why we cannot use this one is because we are looking for a d squared. So we only going for d squared. So our a is equals to 1 because in front of that variable of x, in front of that function of x there, sorry, there's nothing. So it's a is equals to 1. So we'll have minus 1. You see, I'm not squaring the minus. It's minus 1 open bracket squared because it's minus d squared minus 4x, sorry, it's not x, minus 4d plus 4. So this will be equals to sine x divided by, so you'll have minus 1, okay, you'll have minus 4d minus, okay, so you'll have 4 minus 1, which is plus 3. So here we're going to use the reciprocal method. So you have to multiply by minus 4d minus 3 divided by minus 4d minus 3. So you multiply by the opposite of that denominator there. That's the method that you have to use. So always when you are left with this, you multiply with the inverse of that. The only sign that changes is this one. So as you can see, you cannot change the one with d, you only change the one between d and the other number. Okay, so now I'll be left with minus 4d sine x minus 4, sorry, minus 3 sine x divided by 16 d squared. So you multiply this, you multiply them, and then I'll be left with minus 9. Okay, so I only multiply the first term and the last term. Okay, and then this d means derivative, so I'll differentiate that. So I'll be left with minus cos, I'll be left with minus cos x minus 3 sine x divided by, so the d, it means you differentiate whatever that you have in front there. So if it was d 3x, it means we're going to differentiate 3x, meaning you're going to be left with 3. So that's what it means. That d means derivative. But then if it was 1 over d sine x, it means I'm integrating sine x, meaning I'll get cos x. So there's a difference between 1 over d and d. 1 over d, it means integration. D times a variable, it means differentiation. Okay, so I have 16, you see there, now I have the squared, and on top there I've got trigonometric functions. You see, I've got trigonometric functions and d squared. Remember, trigonometric functions only works for d squared. which means d squared is equal to a squared. A squared is equal to minus d. Okay, so we're gonna do that. Open the bracket. We don't want to see d squared. Whenever you have a numerator as your trigonometric function, we don't want to see d squared. The moment you see d squared, you have to substitute. So that's what I'm gonna do. Let me do this. So I have to use two brackets here, the outside one and the inside. So I have to square it like this. Yes, just like this. Minus 9. Then I'll have minus 4 cos x minus 3 sin x divided by minus 16 minus 9. Okay, then you have your final answer. So you can combine them, it's fine. Cos x minus 3 sin x, and then you divide there. So here you get minus 25. So you can split them and divide them individually if you want to. If you have any question, please let me know in the comment section below. And also please do remember to join our website at www.coordinatedacademy.com. So you'll find basic mathematics equations there and solutions. And if you want to join our online lessons, please do text me on WhatsApp. So you go to www.coordinatedacademy.com. Then you go to third year mathematics. You click there, start learning. Then you'll see each topic is there. If you want the operators, you click there. You will find videos and solutions. And that's how you get assistance. Thank you for watching.